explainer. Today, we're diving into a piece of tech that lets you run a completely separate computer, say a Linux machine, as just another app on your current PC or Mac. It's called a virtual machine, and it is, without a doubt, one of the invisible engines that powers our modern digital world. All right, let's kick things off with a scenario you might have run into. You've got your trusty Windows PC, right? But there's this one program you absolutely need that only runs on Linux. Or maybe you're a Mac user and you just need to test something in a Windows environment. What are your options? I mean, you could go out and buy a whole new laptop, or you could tap into a much smarter, much more elegant solution, a fully functional digital computer that lives entirely inside the one you already own. This isn't science fiction, it's a powerful technology called virtualization. So, what is this thing, really? Well, the best way to think about it is like one of those Russian matryoshka dolls. A computer neatly nested right inside another computer. Okay, so the official name for this is a virtual machine, or just VM for short, and it really is what it sounds like an entire computer system. We're talking CPU, memory, storage, networking, the whole shebang that's created entirely out of software. It just runs like any other program on your physical machine, which in this world we call the host. I know what you're thinking. That sounds kind of impossible, right? How can you possibly have a whole separate computer with its own operating system running inside an application without everything just grinding to a halt? Well, let's pull back the curtain. The secret sauce, the real star of this whole operation, is a special piece of software called a hypervisor. You can think of it as the ultimate traffic cop or project manager, and its whole job is to make this crazy balancing act possible. So here's what the hypervisor does. It takes a look at your computer's actual physical hardware, all those CPU cores, all that RAM, your hard drive, and it basically lies to the virtual machines. It creates these virtual imaginary versions of those resources and then carves them up, giving each VM its own dedicated, totally isolated slice to play with. Now, these hypervisors come in two main flavors. You've got Type 1 or bare metal. This thing is the operating system running right on the server hardware for maximum power. Think about the giant data centers that run things like Netflix. That's Type 1 territory. Then there's Type 2, which is the kind you'd probably mess around with at home. It's just an app, like VirtualBox, that you install on Windows or Mac OS, and it lets you fire up a Linux VM right there on your desktop. And even though this all sounds super technical, modern software has made setting up a VM surprisingly simple. It's usually just a step-by-step wizard. You tell it, hey, give my new VM this much disk space and this much memory. Point it to the installer for your guest operating system, and the hypervisor pretty much handles the rest. Okay, so the tech is really cool. I get it. But why? Why would you actually go through the trouble of creating a computer inside your computer? Well, this is where VMs really start to show off their superpowers. Well, it turns out the reasons are pretty much endless. For a software developer, it's like having a perfectly clean lab to build and test new code. For a big company, it's a way to cram 10 different servers onto one physical machine, saving a fortune on hardware and electricity. And for you, it could be the ultimate safe sandbox to open that weird email attachment without ever risking your main computer. And that last point gets to the most important concept of all, isolation. This is the golden rule. A virus that infects your Windows VM literally cannot touch your host Mac operating system. If an app completely crashes your guest Linux machine, your main computer just keeps humming along without a care in the world. What happens in the VM stays in the VM. And that powerful idea of isolation is what unlocks all these other huge advantages. You get massively enhanced security, you get incredible flexibility to run whatever OS you want on any hardware. For businesses, the cost and energy savings are just enormous. And get this, because a VM is really just a handful of files, you can back up, clone, or even move an entire computer in a matter of minutes. That's a total game changer. But here's the thing. This whole idea of creating a virtual version of something physical, it doesn't just stop with a computer. The VM is really just the most famous citizen in a much, much bigger universe. The core concept here is called virtualization, and it's honestly one of the most important technological ideas of the last few decades. It's all about taking physical, clunky resources and creating more powerful, flexible, logical versions of them in software. It is the absolute bedrock of what we call cloud computing. And you can see how this one core idea just branches out everywhere. We've been talking about hardware virtualization, making VMs, but you can also virtualize storage, lumping dozens of physical hard drives together into one giant virtual pool. You can virtualize networks, building entire secure network infrastructures with just software. You can even virtualize your entire desktop and stream it from a server, which is exactly how a lot of companies are handling remote work these days. Okay, we have covered a ton of ground, so let's zoom out for a second and just lock in the absolute essentials you need to remember from all this. So if you remember just three things, make it these. Number one, a VM is a computer inside a computer, built completely out of software. Number two, the hypervisor is that magic piece of software that makes it all work by managing and sharing the physical resources. And number three, its real power comes from providing incredible isolation, flexibility, and efficiency. When you stop and look around, virtualization is everywhere.